Hello and welcome to Lesson 3 of Home Science Lessons with Mr. Mac. Lesson 3 is explaining and investigating resistance. Remember, as always, put away your phones, shut down any windows that are going to be a distraction on your computer, have some pen and paper ready, and be ready to listen and work hard and try and do this whole session in one go. So if you need to pause the video to get your pen and paper and to do those things, do so now, please. Okay, so the lesson today is going to follow the normal pre-science science lesson design of having some time for retrieval practice, some time for teacher instruction from me, some modeling under the camera, some time to embed and drill, and then some time to practice doing some retrieval of the new information that you've learned. Okay, last lesson was on voltage, current, and resistance. And I set some questions for you, calculating potential difference or resistance, things like that. And I promised that the answers would be there next lesson. So if you've had a go at this already, the answers would appear in a sec. If you haven't had a go and didn't do the last lesson, you might want to have a go now at slot 2. There's the first page. And there's the second page. So you may want to pause your video, rewind, have a go at those questions. If you don't and you've already done it, here are the answers. Okay, as I said earlier, there's going to be some retrieval practice from old topics. And your first retrieval slide today is going to be a dot and cross diagram showing the outer shell and a dot and cross diagram of the electrons in sodium chloride and magnesium chloride. So pause the video now and have a go. Okay, and here are the answers to those. Sodium chloride, magnesium chloride. Slide 2 of retrieval is diamond and graphite. What type of structures in diamond give it a high melting point and make it hard? In graphite, what sort of structures give it a high melting point, make it soft, and allow it to conduct electricity? Pause, have a go. And here are the answers. CB stands for covalent bond. Next slide. This slide is based on the work from last time. Again, have a go. Pause. Here are the answers. Okay, so our new learning today, obviously we can't do this experiment at home, but here's a diagram for the experiment for investigating how the length of a wire affects its resistance. Have a look at it, write it out in bullet points or as a paragraph, and that's the method that you need to know. It's a required practical. Here's a set of typical results. The potential difference and the current you would have been measuring using the circuit that looked like this. And voltage divided by current will allow you to calculate the resistance for each length of wire. And here's some typical results. Okay, it's now time to do some modeling under the camera to explain those results. Why did resistance change as the length of the wire changed? And why does resistance increase as the length of the wire increases? So before we go on and embed that new knowledge, let's have a little go at modeling some of this new content under the camera. Okay, so we've got some symbols and signs first of all. So in this case, a metal wire the picture looks like that. A metal ion is a circle with a plus in it. When it's cold, when it's hot, the circle with a plus in it has got a couple of like commas around it to show that it's moving quite quickly. Delocalized electron is an electron that is free to move. And it looks a bit like that. There's a dot when it's not moving, and that arrow just means that it's moving. So a current is a flow of electrons or charge, and we represent it with this dot and arrow to show that the free electron is actually moving through the wire. Potential difference pushes electrons round the circuit, and resistance is the slowing down of the flow of electrons caused by electrons bumping into ions. So a pictorial representation of this would be your ion, which is moving about, and your free electron trying to move past it in the wire. So knowing all those symbols, we can now draw a flow map to explain why resistance increases as the length of the wire increases. So here's our wire. We're going to draw 4 metal ions. And we're going to draw the free electrons that are moving between these ions, trying to get through the wire. So metals are made from positive ions surrounded by free electrons. Okay, so you can rewind this if you need to go back and look at anything, but this is your new information for today. Okay, so make sure you're writing it down somewhere, please. Okay, so our next box is a shorter piece of wire. This one's only got 3 ions in a row. And we've got our free electrons. In a short wire, there are fewer positive ions. So what does this mean in terms of resistance? Less electrons bump into positive ions, so resistance is low. And we can represent this short wire with our metal ions and our free electrons moving through. Okay, so what about with a longer wire? So we're going to make this one much longer this time, and it looks like it's a little bit wider as well, but that's just the way the diagrams come out. So we've got our metal ions, we've got our wire, and we have our electrons moving through, trying to get through the wire. In a longer wire, there are more positive ions. Okay, so that makes it harder for the electrons to get through because there are more collisions. So, more electrons bump into positive ions. So, resistance is more. There are more collisions between free electrons and ions. So if I was to draw this longer wire down here, just below, again, I'm drawing the metal ions with this plus charge, and then these free electrons find it much harder to get through the longer wire. There are more positive metal ions that they could collide with. So in essence, the longer the wire, the more positive ions there are, the more collisions between free electrons and ions there are, and the harder it is for the free electrons to get through the wire. Okay, so there's our whole diagram there. There's our model of the wire. There's our short wire, less collisions. There's our longer wire, more ions, more collisions, harder for the electrons to get through. So if you need to, pause the video and spend some time doing some drill. What does drill mean? If you haven't done this before, well, drill is thrill, also, we need to remember. But drill means getting your notes, reading them, covering them up, and getting someone else to test you on them to see if you can remember them. Your notes from the experiment, the method, and your notes on the explanation of why resistance increases as the length of the wire increases. So you can get someone to test you on it, or you can cover it up, write it out on a blank piece of paper, look, cover, write, check style. So if you could have a go at that now, please. Okay. Now what I want you to do is to get out a blank piece of paper and write down as much as you can remember about the experiment method and also the explanation on the effect of length of a wire and resistance. So if you need to go back and rewind the video to have another look at it, that's fine. If you need more time to look, cover, check, that's fine. But have a go, see how much you can actually remember of this new information. Okay, thank you for taking part in the lesson today and doing it to the best of your ability. Our next lesson is going to be on resistance in a lamp resistor, and diode. So thank you very much for having a go at the activities today. Hopefully it's useful for you. Remember, in the time between this lesson and your next lesson, if you could do some retrieval practice on the new information that you've learned, because weekly recall tests are still happening. Complete any of the memory or slot activities that you've seen in today's lesson, and also share with your friends to make sure that as many people are getting access to these learning opportunities as possible. So just need to say now, thank you very much for listening, and I'll see you again sometime soon. Bye-bye.